Morning, Dr. Chaklam. Can you hear my voice? We will start our general lecture in 2 minutes now. So, for all participants, please use the virtual background that already shared in the public chat. Okay, I will try to ask the host to let you unmute. Okay, Dr. Chaklam, how about now? Can you unmute yourself?
Yes. I think I'm able to do that. By the way, good morning, Ade.
Good morning.
Thank you very much for inviting.
You're welcome. It's our honor, and also it's a pleasure for us to have you this morning to talk with our students. So we will start in 1 more minute. How is Bangkok today? Everything is.
We are almost back to normal. Yeah. So hopefully only good news.
Not. Maybe next year we can meet offline together for another session, maybe in AIT or maybe in Medan.
Definitely. I will be happy to. Yeah.
Okay, thank you very much. Let's start our event. Now is the time. So I will let the master of ceremony to open this event.
Thank you very much, Mr. Andre, Mr. Ade. Excellency, distinguished guests, Dr. Chaklam, and all participants, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. Good morning. We are delighted to welcome you to International General Lecture of the Advanced Machine Learning. Okay, we are now going to listen to the welcoming speech delivered by the head of the Computer Science Doctoral Program. Please welcome Dr. Poltak Siombing.
Thank you, Mr. Indra. Good morning, everyone. The Honorable, the Dean of Faculty of Computer Science and Information Technology, Universitas Sumatera Utara, Dr. Maya Silvi Lydia, Master of Science. Keynote speakers, Dr. Chaklam Silpasuwanchai from Department of International and Computer and Communication Technology in School of Engineering and Technology, Asian Institute of Technology, Thailand. Honorable Dr. Ade Candra as the head of the Informatic Master Department, Faculty of Computer Science and Information Technology, Universitas Sumatera Utara. Indra Aulia, Master of Science as the Secretary of Informatic Master Department, Faculty of Computer Science and Information Technology, Universitas Sumatera Utara. All of the participants. Good morning, everyone. I am Dr. Polta Siombing as the chair of the Computer Science Doctoral Department, Faculty of Computer Science and Information Technology, Universitas Sumatera Utara. I congratulate you on joining us in the general lecture special topic in advanced machine learning via Zoom this morning. This morning, we invited Dr. Chaklam Silpasuwanchai from Department of Information and Communication Technology, School of Engineering and Technology, Asian Institute of Technology, Thailand. Thank you for coming, Dr. Chaklam. I hope all the participants can follow this event with focus and seriously from the beginning up to the end. Thank you very much for your time, Dr. Chaklam Silpasuwanchai. Thank you all. Good morning.
Thank you very much, Dr. Paul Siombing, for welcoming speech. Before the next meeting, we will hold a photo session. All participants, please turn on your Zoom web camera and give the best smile. Okay, we have 3 pages in Zoom. I will take the first page. 1, 2, 3. Page. Okay. The second page. 1, 2, 3. Okay. The last page. Okay. Okay, we are now continuing our event to the next agenda. That is to hear the speaker, which will be delivered by Dr. Chaklam Silpasuwanchai from Asian Institute of Technology, Thailand. The speech will be moderated by Dr. Engineering Ade Candra. So please welcome Dr. Chaklam and Dr. Ade.
Thank you very much, Mr. Indra Aulia. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Morning, Chaklam. Thank you very much for spending your time to join with us to share your research experience, your best practice in conducting your research, and also managing your student and your lab. And then we are very happy and said it's honor for us to have you here. Also, we hope next year we can hang out together in AIT or maybe in Medan to have more deeper conversation with many kind of research topics, especially related with your lab. So for all the participants for today's session, our general lecture, before we start, I would like to share a short profile of Dr. Chaklam. So please allow me to share the screen. Okay, Mr. Indra, can you see my screen?
Not yet.
Not yet.
Okay.
Okay.
Yes,
Okay.
already.
Okay. So for all the participants, I would like to introduce Dr. Chaklam, the Silpasuwanchai. He's a researcher, lecturer from Asian Institute of Technology, Thailand. You can see his profile from chaklam.com. Also contact him by email via chaklam@ait.ac. Dr. Chaklam received PhD and also postdoctoral under the supervision of Professor Xiang Siren from Kochi University of Technology, Japan. And now he serves as assistant professor at the Computer Science and Information Management Program at Asian Institute of Technology, Thailand. He also managed the AIT brand lab that focuses on deep learning on brain and text for the purpose of health and well-being. So I think many students or other participants has interest with the deep learning, especially for text classification or text mining, something like that. So it is a good moment for you to discuss with Dr. Chaklam. And then he received many research grants. I think most of them from Japan, like JST, Japan Science and Technology Agency, as I remember. So now Dr. Chaklam managed some course from human-computer interaction and data structure, algorithm, software architecture design, also programming for data science. I think the last course is for the BSAI program that sent in our university. I think that's all for the introduction for Dr. Chaklam. Now let's start our session. We will listen the presentation from Dr. Chaklam. So now it's 9:08. I think we can have discussion or maybe listen to the presentation from Dr. Chaklam until 10:30. So okay, Dr. Chaklam will have about 90 minutes to also discuss with the student. So please, Dr. Chaklam, time is yours.
So thank you very much, Ade, for introducing me, and thank you everyone for inviting me to such an important talk. So my name is Chaklam, and I'm actually from Hong Kong, and I came to Thailand when I was around 15, and my research is mostly about deep learning, as everyone knows, and mostly I have worked with temporal data, mostly time-based data. For example, the EEG signals, spectroscopy, and also the NLP, which is one of my favorite. Right. Of course, I also work with the images, but probably signals and text something that I'm more interested in having more affinity on it. But so today I was invited to talk about machine learning. I'm not sure how much you guys know, so I will try to speak from the beginning and maybe give you guys some of the glimpse of what other people are doing, even in today in this year. All right. So thank you very much, and let's start today workshop. All right, so I titled today's class as machine learning and deep learning. So I'm gonna go over a little bit on what is actually machine learning, and then I'm gonna jump to deep learning. All right, so we can actually understand the whole history about about the history of AI. All right. Of course, my name is Chaklam. I'm from the School of Engineering and Technology. I'm actually a director for the Center for Health and Wellness Technologies and IoT, right? Today we're going to cover quite a lot of topics, and it's aimed to more like a discussion, more like a panel, and to give you guys a better landscape of what people are doing nowadays. And of course, for those who have no idea about machine learning and deep learning, hopefully today's class would be helpful to introduce you to the world of AI and machine learning and deep learning, right? So we're going to start with a one-page, a very brief history of deep learning and AI, so you can understand what people are doing, right? We have talked about AI for so long, for almost 10 years. It is easy to get lost. So I include this one page, and then I provide a brief introduction, what is actually AI. And then I classified AI techniques into actually two way, and then actually explain them what are the differences, and try to position deep learning onto this classification taxonomy, you can say. And of course, we're going to visit some examples. We're going to visit some classic examples of deep learning, and also the more interestingly, we're going to visit some of the more contemporary, more recent publications on deep learning, so you can get a good idea of what people are doing. And lastly, I'm going to talk about the limits of AI today. I don't want you to all feel very hyped by watching all of these lectures, but I want to stop you and to think that, hey, AI is still very far from what we want it to be. So what should be done, right? So that is the last slide and a couple of slides that I want you to take away. All right. So the history is can be actually summarized into the following bullets. First, we have the Industrial Revolution, right? In which in the year 1700s, we have steam engines and machine tools, right? In which countries that are able to do this kind of industrial revolution actually benefits, right? And it is no surprise that those countries, for example, England, France, right, Japan, right, those countries actually benefits from this revolution, right? So the question is, what is the next revolution, right? Of course, we already have the IT revolution, in which computers, Google, Facebook, they are the symbol of change, right? So now after Google and Facebook, now people are asking, what is the next era, right? And a lot of people predicted that it would be no surprise that it would be an AI era, in which a lot of things will be automated, right? Who knows? Who knows? So in 1943, this is the first time in which a neural network is being discussed, and it actually discussed by neurophysiologists, basically people who are very good at brain, by Professor Warren, and another guy is Walter Betts. They both are very famous. Everyone know them in the world of AI. Of course, they've already passed away. And they talk about how the brain actually works, right? And they say that, hey, if we can actually model them in a very simple way using electrical circuits, because the brain is actually electrical machines, then probably we can simulate a human, right? So that is probably their dream. And even today, it's still not achieved, but this is a very, very good dream, right? So it starts from this time, right? And in 1951, Alan Turing, who is the author of the final state machine, he talks actually about the power of machine. He believes that once machine reach a certain capability, they will surpass humans. They will surpass humans at certain things, right? So actually, I think humans, machine already surpass humans at certain things, right? In which we're going to see it shortly. In 1957 and 1962, perceptron by Frank Rosenblatt, he talked about how we can actually simulate a computer generated multi-layer perceptrons in order to predict something, right? And then our perceptron doesn't really get a lot of reception because it is not able to learn. That is the most important thing, right? It is able to feed forward, but it's not able to learn, right? Basically, take that feedback of the loss and try to backpropagate, right? And it's not popularized until the 1970 by Silpasuwanchai, by Professor Seppo on his topic backpropagation, right? In which this is the idea in which you feed forward the network, and then the network, once it calculates the loss, is try to backpropagate and try to see what are the things that need to be changed in the network to make it better. So this process is called learning, right? And you do this several loops, and then probably you get a better idea. During this time, it's the same time in which we have the concept like IBM and also the IMF, all right? And then in 1979 to 98, we have an idea of CNN, right, by Kunihigo, right? And also we have a first data set, which called MNIST, is basically an image of digits, and also long shot term memory, which is a much more better way for recurrent neural network that handles vanishing gradients, right? And bidirectional array, right? During 1979, CNN is still not so positive. The reason is because there's no such thing as deep learning, right? So there's only one layer of CNN, right? So during that time, CNN has still not been that cool, right? But I think during 2006, we have something called deep learning, in which Yoshua Bengio, Geoffrey Hinton, and Jan LeCun, these three giants, basically people call them the godfathers of deep learning. They are the one that actually proposed the idea of stacking a lot of layers together, right, and call them deep learning, right? So they also won the Turing Award, which is similar to Nobel Prize in computer science. And of course, in 2009, we got a huge data set called ImageNet. This is the key. Because of this data set, later on, it will comes a pool of models that actually improve on the computer vision side, right? So I think ImageNet has a huge contribution to the community, right? And of course, the first CNN that is very successful to work on ImageNet is AlexNet, and it's no surprise by Alex Krasovsky, right? And then in 2014, Ian Goodfellow. By the way, it is good to know that Alex is actually the advisor of Geoffrey Hinton, right? And Ian Goodfellow is an advisee of Yoshua Bengio, right? It's no surprise. And then in 2014, there's something called generative adversarial networks, and it's created to actually create something, right? So people say that, hey, you can use CNN to predict image, you can use LSTM to predict signal, or whatever things that is time series. But Ian Goodfellow say that, hey, we can actually create a neural network that can generate something. For example, generate music, generate arts, right? So that is it. Of course, in 2016, I think everyone heard in the news about AlphaGo. And then in 2017 until now, the most important things that I would not say most important, but the recent things that a lot of people talk about is transformers. And I don't want you to think too much about transformers, but I want you to think about the fundamental mechanisms of transformers, which is attention. All right. So this is the brief history of deep learning. The next topic we're going to talk about is briefly introducing what is AI, right? And my definition is very simple. That is, AI is basically machines, right? That you are built to solve problems or make automated decisions, all right? And I think automated is the first keywords, and the second keywords to solve problems, right? And there are actually two types of AI that I can imagine. The one that we call strong, right? And in this kind of category, we say that these computers actually surpass humans, or they actually engage in abstract reasoning, all right? Unfortunately, this is not what we have today, right? This is not what we have today, and it's very far. So we are not in the category of a strong AI. In the second category, we have something called weak AI, and this weak AI is actually very good at detecting patterns. All right, and this is the dominant mode of AI today. Right, and a good question that people have is why AI now, right? Actually, I think AI started from since 1940, something like that, right? Neural network, but even today, the normal researchers, who is not having a huge machine, can do deep learning, right? I think that is the key, right? And the question is why we are now able to make AI pervasive and everyone can do AI. And the reason is, I think, at least four. First is that there are a huge amount of data. The computational power is increasing at much lower cost, right? So nowadays we can go to the mall and buy some GPU at much lower price. Of course, the Bitcoin make the price higher, but it's still relatively lower compared to before 5 years ago. You can compare. And then, of course, we got a lot of model progress. Nowadays, we have a much more powerful deep learning techniques. Lastly, we have lots of available tools, programming like PyTorch, TensorFlow, and even non-technical people here. I guess that there are a lot of people here listening to me now. There are a lot of tools that not only me, but any people here that can use deep learning. I think this is the key. This is the key, because usually human breakthroughs does not happen within the field. Surprisingly, you can go and try to see whether this is true or not. But this is actually what I observed. But instead, the human breakthroughs is usually some people outside the fields look at deep learning at different angle and try to apply it, right? So I think this is a very important breakthrough in which allows people from different fields to look at deep learning at different angles and leads to a huge breakthrough. Right? And now let's talk about the AI techniques, which involve the rule-based, the machine learning-based, and also deep learning, all right? And try to position them and try to see how are they different, how are they similar. So in AI, we can say that there are actually two techniques. The first is the logic and rule-based, right? In which for those who program a lot, you probably know that it's nothing but just writing if else, right? We can do this, right? Even in our Excel, we can do this kind of simple logic and rule-based, right? And we can say this is a simple AI, right? We can actually say this is AI because it can solve problems. And when we open the Excel, it can automatically refresh and then give us automated decisions, right? So that they are actually AI, but we should say that they are not so smart AI, right? They are just a logic and rule-based AI, right? And not to overlook them, they are actually powerful, right? But the second techniques that we can actually see is basically machine learning based, which is a pattern based. What is pattern based is basically try to observe the data at hand and try to instill whether there are any patterns that I can get. And then using that patterns, I try to predict, right? So for the logic and rule-based is basically a top-down rules, right? And it's created by humans. And then the example is a rule-based chatbot. Right? A lot of people talk about chatbot, but the simplest chatbot you can think is you basically list all the rules you have, right? And then say that, hey, if people ask this, please answer this, right? This is probably 80% of what we have in the market currently when people talk about chatbot, right? It's not so smart, but it can finish the job at hand if the query is not that complex, right? For example, you can ask like, what is the available hotel room, right? And you can program that in the computers, right? So in that, I don't think that you need a very complicated chatbot. You just need a rule-based chatbot. Advantage is easy and predictable because we are the one who make the rules, so we know what happens. The disadvantage is it's not so smart. Machine learning, in machine learning, the idea is that the way it finds the patterns is using statistics and optimization, right? So using statistics, it can actually using some probability, right? In order to actually see whether there's a high probability that these patterns belong to this class, for example, right? And the cool thing about machine learning is that it can improve over time. That is, you can supply more data, and then it can actually improve over time. And it's a dominant mode of AI. A good example is basically pattern-based chatbot, right? So you can feed a lot of messages, question and answer to the machines, and the machines try to make sense, right? What are the patterns inside the message that people ask and question, right? And then try to create a robot that can answer the correct sentence. The advantage is smarter over time, but everything in the world, when it's very powerful, there's always a limitation, right? And this is the same as machine learning. That is, it's unpredictable, right? Because you are stacking a lot of layers like this. And if you have a lot of text, you stack a lot of layers, suddenly you actually don't know what is happening, right? So the key problem of machine learning, I would say, is related to this unpredictability, right? In which we don't really know what happens. And this is the biggest danger of AI. That is, maybe we created robots and we say the robot is very smart. It can read text, it can understand humans, it can do a lot of stuff. But one day it may malfunction because of something that we don't know, right? So that is something that we have to think about. There are a lot of types of learning, right? And first is a supervised learning, in which we are learning with a label training set, which means that we supply the data with the answer, with the ground truth, right? For example, we say that this image is cat, this image is dog. Cat and dog is the ground truth, and the image is the data, right? So we supply the image with the ground truth to the computers and let the computers learn, right, through the backpropagation process to understand that, hey, this is a cat and this is a dog, right? So this is a supervised learning. Supervised learning is the most predominant, dominant type of learning. I would say 80% of all the learning in the industry is supervised, right? In the second type, what if we don't have the ground truth? That is, maybe I have a lot of transactions, right? Maybe you are working in a retail business and you have a lot of transactions. Do you have a ground truth? You don't know, but you want to segment the customers based on different segment, right? Maybe you're doing customer segmentations, right? So you're asking, hey, so what are the different groups? So you don't have ground truth. You don't even know what are the groups, but you only have the data, right? So you give this data to the machines, and hopefully the machines can make sense that, hey, this group share very similar behavior, and there's another group that share another set of behaviors, right? So this is called unsupervised learning. The third type is reinforcement learning, and this is the type that in which you ask the machines that, hey, please do something, and if you do it right, I'm going to give you rewards. If you do it wrong, I'm going to give you penalty, right? So you can every day you can simulate 1 million loops of this, right? And eventually the machine can do much better than humans. Example is driving, self-driving. You can ask the machine to simulate, right? To simulate driving around the country 1 million times. 1 million times, right? And then every time if it hits something, you give a penalty, right? Every time it is successfully able to pass the obstacle, you give some rewards, right? And then based on this complex equation, over 1 million times every day for 1 year, I believe that the machines will be it will be very, very smart, right? And that is called reinforcement. Lastly is some idea called generative learning, in which later on I'm gonna maybe show the architecture, and then it's basically the idea of we have some sample images, or we have some sample text, or we have some sample something, anything you want to generate. You provide the samples, right? And then provide the samples to the computers, and the computers is able to generate something that is very, very simple, right? Very, very simple. So here, this is just some example. This is both of this is supervised learning, in which they can be regression, they can be classification, depending on the ground truth, whether it's continuous or is discrete. There's also unsupervised learning, in which you don't have the ground truth, so you just give everything to the machines, and probably it can give you, it tells you something about the data, right? This is reinforcement learning, so you can train a machine to play this kind of game, and then it will eventually be better than humans. There's no way that humans can be better, because for those who cannot imagine, I think the idea is something like this. Humans, every day, you probably can practice maybe 3 or 4 times maximum, right? Using your full brain power. But computers, every day it can play the games 1 million times every day, right? So in this kind of very, very specific task, computers can do much better than humans, even though he is an expert. And this is a generative learning, in which you can see these images, right? This is actually created by the machines, right? By learning from very famous artists, and try to simulate that, right? We're going to talk about this later on, right? So there's a bunch of supervised learning algorithms. By the way, this is the classic one, right? The traditional one, in which for regression, the Y is continuous, and for classification, the Y is, the ground truth is basically groups. And there's a lot of algorithms that you can actually use. For unsupervised learning, there are 2 types. First is clustering, in which you want to cluster into different groups. And then another type of unsupervised learning is a dimensionality reduction, in which you want to reduce the damage, right? Right? Now let's come to deep learning, right? You have to a common question is what is deep learning and what is the difference between deep learning, AI, and machine learning, right? And here I'm just going to give you a very simple idea. AI is the dream, right? AI is the dream. AI is the goal that we want to go. That is, we want to create some machine that is like humans or even better than humans. AI is the dream, right? And in order to do this dream, there's so many things we need to do, right? Not only software, we need to do a lot about hardware too, right? But looking at the software, one good way is using machine learning. That is using something called pattern-based, right? In order to understand the different things, right? So that is machine learning, and there are many types of learning: right? Supervised learning, unsupervised learning, reinforcement learning, and generative learning, right? So that is machine learning, right? And we have a lot of algorithms, right? But the classic machine learning algorithms like regression, like support vector machines, they are very weak because they are not weak. Of course, they are not so weak, but they are not powerful enough to learn complex relationships in a very complicated data, right? So people create another technique, which is a subcategory of machine learning called deep learning. And the idea is that using try to understand the patterns using layers of network, right? So that is the position of the deep learning, right? And one cool thing about deep learning is that in the traditional machine learning, maybe you guys can imagine support vector machines, or okay, for those who have not come from the machine learning idea, you may imagine that you have some Excel file, and then you have some Excel file with a lot of columns, right? And then you try to create new columns, right, that are useful to predict something that you want to predict, right? And then you input these features, and features is basically the columns, right? Maybe you want to forecast the sales, right? So you may want to see that, okay, how many items are being sold, right? So those are the columns, right? So those columns we call features, right? And then we feed these columns into some model. And the simplest model humans have is basically the average, right? The mean, right? And probably everyone uses the mean model, right? But of course, we can also feed in into ANOVA, t-test, and even higher predictive power like regression or support vector machines. Then we get the answer, right? So that is the classic way of doing machine learning. But in deep learning, you don't have to choose the columns. You don't have to clean the columns. You just feed the whole raw input to the deep learning, and the deep learning has a mechanism to choose which features to take, how much each feature to take, right? So that is something that is very powerful of deep learning. All right. So maybe I can talk just a little bit what are the common architectures that people use in deep learning, right? And hopefully I don't go too fast, but I will just explain how different architecture works, right? So the first architecture is a recurrent neural network, right? And a recurrent neural network is used for temporal data. And when I say temporal data, it means there's a time. And when I say time, I mean that the sequence, right, in which things happens matters, right? So time series like stock price, EEG signal, electrical signals, and also text, right? I heard from Professor Ade, right, that you guys are very interested in NLP, right? So if you're interested in NLP, then you must understand IAM to the heart, right? And all the history up to now, right? So this is how vanilla and recurrent neural network works, in which you are basically having one linear layer, and then you just recursively pass in the same weights, right? And then you output the hidden states, right? And hopefully you try to imagine that the last hidden states can be used for classification for sequence to sequence, right? So you can imagine this is like I love Python programming, but right, and then this HT, the last hidden state, is trying to predict the next row. Maybe that would be one of the use cases of this recurrent neural network, right? But of course, a recurrent neural network, as you guys remember from the history, is from 1970, right? So it's very old, and it suffers from one big problem, which is vanishing gradients, in which I'm not gonna maybe too technical, but the idea is basically when it backpropagate, it is not so effective. When you feed forward the weight and it's trying to backpropagate, it's not so effective because the gradients is got low, right? So then we have another variant called long short-term, in which it has something called the context state that can able to record the information much better. We also have a convolutional neural network. So for anyone here who are interested in doing images, you should look at convolutional neural network, right? And the idea is very simple. That is, you have some square, which we call kernel or filter, and you look at each of the patch one by one, right? And you multiply with some weights, right? And then that result into feature maps, and this feature maps is so slowly convoluted, and then pass into some fully connected layers, and then output some class, right? And you may say, hey, Chucky, I don't really understand how this works. Like, can you speak?
Mantap ya Mas. Bismillah. Ini kecil kan?
Yes. So you may ask me, Chucky, can you speak in a human language? And the idea is very simple. That is, when you look at this, how do you know this is a robot? Well, you look at each of the patches, right? So you can divide these images into patches. When I say patches, it means you divide it into grid. And then maybe you take this grid and refer to your brain, right? See whether that is related to the robot. No, this part is not related to the robot, but maybe this part, right? Oh, this patches is related to robots, right? So and maybe this spring and this part is related to robots, right? So you basically chop these images into patches, right? Into grid of patches, and then you try to multiply with some weights, and through that backpropagation, you can learn that this is actually a robot, right? So that is like a human way of understanding how convolution works. Of course, convolution neural network suffers when there's a lot of layers, right? And suddenly, if you have a lot of layers, the layers is also suffering from vanishing gradients, right? So then we have something called ResNet, or we call residual neural network, in which we propose the skip connection, right? And I'm not going to go into details because this can go. I can talk this for a long time, but the idea is that by skipping this connection, you allow a more effective one, right? Because who knows? Maybe you don't even need to learn anything. What you already learned is already very good, right? When you're having a lot of layers. Generative adversarial network is for generating music, images, text, whatever you want to generate, right? And the idea is that you just supply music or images to the computers, and the computers can generate it outside. The idea is super simple. You have two models, generator G and D, and they can be CNN if they are images, if you're training to generate images, or they can be LSTM if you are generating music. All right. So no confusion on the generator and discriminator. And then you just generate some images that you have no idea what is it, and then send this generated images to the discriminator, right? So this guy is the police. It's like the police, and it's trying to say whether this is a real or fake, right? And then the discriminator or the police will send back the results, whether it's fake or real. And if it's fake, the bad guy, you can say the generator is the bad guy, will try to fake, right? Will try to improve the quality of the generated images so that it can try to fool the police, right? And then so they are playing this game back and forth. And you can imagine many times, finally, it will be able to generate very, very cool images. So for example, this is the input, and the computer is able to generate this image. This is the input, and the computers are able to generate this 4 images, for example. The last type, which is a lot of people is talking about, is the attention. Attention, and I don't expect everyone to understand attention by today, a short lecture, but maybe in CNN, it looks like this, right? In which you take a nearby pixel, right? You can imagine this is the one patch in which they are nearby pixel, and then you try to combine them into one number, and then try to convolute them, right? And to across layers. In INN, the input of this will be also inputted into the next input, right? So the current input is dependent on the previous thing, right? So this is INN. But in attention, it may look silly, but it works very well. The idea is that you just correlate everything with everything. So attention is about correlation, right? But the reason why we can use attention is because of the computational power, right? So people say that, okay, CNN is good, it's good for image. INN is good, it's good for signal. But now we have a very, very powerful, very powerful machine. We don't need to create, we don't need to use this very specialized network that has some assumption. When I say assumption, it means that CNN is built with the assumption that it's an image, right? INN is built with the assumption that it is a sequence. But what if I say that, hey, I don't need any assumptions. I just input everything and just correlate everything, right? And that would create a network that is very, very generalized, right? And can work well with anything, images, text, right? Signal, whatever you call, right? So this is the idea of attention, right? But of course, there are many disadvantages by doing this philosophy, right? Because you lose the local information, you lose the sequential information, right? So there are many tricks that you need to put on this kind of idea so that it makes it work. Attention, the idea of attention becomes super good when we talk about transformers, which is around 2017. And this is only attention, and it works super well with text, right? And from that on, nowadays we have so many models: BERT, XLNet, Robota, GPT-3, and BERT, right? And Megatron. So all of this come from this architecture called transformers, right? So I have some fun. You guys can go to this link. Not sure I can copy this. No, I can't copy this, but you can actually type in this, right? Maybe I can type on the chat, right? And you guys can try, right? And this is made from transformers, and you can predict the next word. So maybe I type a Python is, and I type tab. This is what it is. I'm not sure it is good or not, but And I also typed something, the meaning of life, and I don't is that we have something to live for. I don't know, but this is what is able to do with the transformers, right? And this is not rule-based. This is completely trained by the model, right? And I would say it's far from good, but it's not bad. And I believe that in 5 years' time, it will be much better, right? So please, you can try. So after a lot of heavy stuff, maybe let's look at more simple stuff like examples and applications, and then less on the technical stuff, and then try to understand broadly what people are doing. All right. So firstly, maybe I go with the classic one, right? So of course, AI for cancer detection is a very good area to work with, and I think the key is now multi-disease, right? In which you have one model that you input the data and it can predict multiple disease, right? So that is one of the good way to work. Another thing that is very useful to work in this area is reinforcement learning, in which you have a initial area, you have an initial model, and you can reinforce it using new data and also using the doctoral supervision, right? So that is also a very good area to work with. Image captioning, you have an image and try to create some sequential text based on that images, right? So this is called image to sequence, right? Image to sequence. Of course, this is what I'm doing in my lab. This is a brain signal classification in which we try to stick on some prosthetic arm or maybe some augmented arm, and then try to use the brain signal as a pattern. Remember, we are looking at patterns, and try to ask the participants to imagine left and right, and then try to move this left arm left and right, for example. Image location prediction. I put this here because I thought this is very cool. That is, you may have some location. I'm not even sure what is this, but then you input to the model, and the model can actually predict where is it. So I think this is a pretty cool, and then so it can actually highlight the probability, right, in which this place belongs to. So for any master students, this is a one good topic. Of course, we can also use deep learning to reduce the data center cooling electricity. So you can see that in Google, if they turn on the modules, they greatly reduce the electrical consumption. But when they turn off, it comes back, right? So definitely deep learning can be used to save energy. Definitely deep learning has been used to forecast the traffic on the mobile networks and try to reduce them, right? One very good term is called edge analytics, in which you try to put a lot of stress on the network and try to see which network actually goes down, right? So it's a very important topic in the area of IoT and wireless communication. And supervised learning, customer segmentation is one that a lot of companies is interested. That means you supply the information, and then hopefully it can do segmentation for you. Here you don't have a ground truth, right? And you don't even know they are true or not, but this is the best the computers can give you. Basket analysis, in which customer buy milk, bread, cereal, the customer to buy milk, sugar, bread, eggs, and the customer to use milk, bread, butter. So by doing this kind of analysis, then you will know that which kind of items are usually put together, right? then you can put your shelf in a way that is very good for sales, I guess. Anomaly detection in wireless network. So you can also understand the wireless network as an unsupervised learning problem. That is, you don't know the ground truth, you don't know what is wrong. So you input the data that is maybe the normal behavior, then you let the computers to try to classify what is abnormal, right? So that is another way you can think about in unsupervised learning. Yes, I think that to come to my research, whenever I don't have ground truth, it's always useful to think about unsupervised learning. And secondly, whenever I want to use it in real time, in which the ground truth is not available, unsupervised learning is extremely useful. Of course, reinforcement learning, you train the computers to play the code with 1 million times, even more than that per day, and then it will always beat the best person in the room. Yes. I want to say that even AI wins human beings. You cannot say that the AI is now gonna be better for humans. That is must be. We must be very careful to talk about that, especially the young scientists, right? The AI is able to beat this human only on code, only on this specific task, right? But if you compare this guy, these computers with this holistic human, there's no way he can beat him because he can learn, he can do something else, right? He can also learn other games, right? So that you cannot compare like that. But in one specific task, we can show that AI can actually beat humans quite convincingly. Of course, in self-driving cars, you can break into supervised learning, in which it focuses on object detection, lane detection, right? But also it focuses on reinforcement learning. That means that every time it hits a pedestrian, it got a penalty. Every time it's reached the location safely, then it got rewards, right? Generative learning, you supply people with images, and then probably the computers can generate images. This is quite funny. That is 3 years ago, I gave the same lecture, and I told the participants very funny things, which I don't want to say it again. That is, I told the participants that, hey, AI won't beat humans. Example, creativity, right? I don't think AI can make images like a drawing, right? But after maybe 1 year after I said, then that this generated adversarial network or GANs is able to create very creative images, right? So yeah, I don't think there's anything that that can stop AI from doing. It's just depending on what kind of neural network can do. But this is the images that is actually generated by computers. Of course, creating music. I'm not so much into this area because I don't listen too much on music. But I heard from my students that they are actually listening to music that is generated by robots, and I was quite surprised. And I asked them why they like it, and they say that it's just good. So I don't know. Maybe you guys can let me know. But yeah, you can actually use a neural network to learn to create music. And the cool stuff about creating music is that you can choose which artist you want, right? And then put all the songs in, and then let this neural network to create music that is as good as that, right? So now let's talk about like 2021. what are people are actually doing nowadays in this year, right? And for example, this is by OpenAI. For those who don't know what is OpenAI, is by the Elon Musk company, right? And they generate image from text caption, right? So for example, you write something like a tapir made of accordion, or a tapir with the textures of an accordion, then it automatically creates this, right? This is another example, illustration of a baby hedgehog in a Christmas sweater walking a dog, right? And it automatically draw this, right? So I think this is a super cool, super cool. And this is zero shot. And the idea is zero shot means that it does not require any training. It just use some pre-trained model and then just able to do this right away, right? So this is called sequence to image model. This is by Google, and they are using GAN. And the idea is that if you want to test some shirts, you can use this program, and then it will automatically put the shirts on the body, right? The idea is using StyleGAN, which is a very specific GAN focused on neural transfer. And neural transfer is the idea in which you learn the patterns in one samples and apply that patterns in another sample, and we call this a neural transfer. So maybe I can type this in the chat, right? Neural transfer, right? And this is very cool. And this is also in 2021. This is the first time in which we can actually detect letters, right? Letters is using aerial images. So you can take photos on the ocean and try to detect what are the letters that are on the ocean, right? So I think this is a huge impact to our world. This is another example in which I think the key contribution is only a single image, right? So by only a single image, you can create a 3D scenes, right? In which you can render it in using in your home, right? So you can use it to try to render at your homes, or you can also just put it into the 3D printer, right? So I think this is a very powerful idea. Of course, we know transformers are very powerful, so why not use it for computer vision, right? And the idea is very simple. We just divide the images into patches, and then feed this into some flattened patches, and then feed it into the transformer, and then hopefully it can classify what are the class, and it's super successful, super successful. It's called a vision transform. This is very similar. This is also neural transfer, in which you learn certain features of the faces, and of course you supply the sketches by the experts, and then try to let the computers try to learn how to actually convert this into this. Right? So I think this is a little bit funny. Maybe get from other images, but anyway, this is something very cool, and it's on ACM transactions on graphics, which is a very good choice. This is another example of creating the whole game using something called game GAN. And so the difficult of creating a game is that there's a series of actions, right? Right. So after you move this, maybe the enemies move in another direction. So in order to create a game engine, you have to know all the possible actions, right? So that is the contribution of this paper, and I think this is super cool. Even though they are making on game, I can imagine that this can be used into video GAN, to create videos of something, right? So this is extremely cool. Brain to image. This is exactly what my lab is doing. Of course, most of my lab is doing NLP, and everything that I just talked in previously is what I do. Mostly focusing on text summarization, sequence-to-sequence translation, chatbot, and also one of the topics that I'm working on is a brain-to-image, in which we are converting the brain signals that we look at some images into the actual image that we are actually looking at, right? This is using idea called generative adversarial, right? So this is directly related to my work. Okay, so I think I have been talking a lot, and hopefully you guys can get something, right? I will share this Google slides to you after my presentation, so don't worry. But probably my last slide and the takeaway is the limits of AI today. I have two things I want to talk about. That is the first, especially for the young scientists, there's so much more to do. All right, that is the main message I want to give you guys for the young scientists. But the second message is I also want to say that AI is also very, very dangerous, right? So that is the two message I want to give. So firstly, every day we heard news about AI, but if you look carefully, of course, it's very, very amazing. But we still don't have something called conscious computers, right? In which the computers can think by themselves, learn by themselves, right? And it's very far from happening. It's only specific task AI only, right? So it can only do a specific task. It cannot imagine a better solution, right? So if we ask them to do this, they will do this, right? So it can never go beyond the patterns. And lastly, in the ethical perspective, we have to think about, could AI detriment us in some ways? When I'm in Japan, I work with a great philosopher. His name is called John Cahill, and he always, every day, he always asks me, Chucky, what are you doing? And I'm saying, hey, I'm doing deep learning. And he always talk to me in the same fashion. Chucky, it's good that you do it on deep learning, right? But what if your deep learning make humans atrophy? And then I asked him, what do you mean by atrophy? He basically said, hey, maybe our memory got reduced, right? Back then I can reduce all my phone's number. Nowadays I cannot, right? So yeah. And maybe I can be less smart because every day I just use Google. So what do you think? Maybe using deep learning can make me atrophy. So every day is just a brain washing me. But I think there's a partial truth in it. But I also see a lot of optimism that if humans collectively we are imagining a good world, a positive world, then we can control it, right? So we have to be optimistic about this. In my last slide, this is made this specifically for researchers. Out of these participants, probably 50% of you are researchers. So you may wonder what are the good research topics. One of the good ideas is to do something called week zero or field shot learning, in which we try to learn something that is we just train one time or a few times and then it works, right? Then the idea is that we don't need a lot of calibration. Reinforcement learning, I think there's a huge room for improvement by combining supervised learning and reinforcement learning, right? If we can combine them, then it would be perfect, right? So there are a lot of rooms to do reinforcement learning. Cross-modal learning, text to image, image to text, EEG to text, EEG to image, right? So those kind of training is very, very useful. To understand this, maybe it's good to understand the philosophy, right? And the philosophy is that we humans, we can understand the same thing, but in different modalities, right? We can look at image and we know that this is a brain. We can look at we can read text, right? Maybe hamburgers. And then we also know that that is hamburgers, right? We can imagine, and we can also know that that is hamburgers, right? So the idea is how we can train a machine that can do the same thing like humans. That is cross-modal, right? That is that they can understand the same thing, but in different modalities. Transfer learning are super important. That is try to understand the effective transfer of learning between tasks. That means if I change the model across tasks and participants, suddenly the model stops working, right? Model compression, we don't want the model to be too big. Like Megatron by NVIDIA is so big, 8.3 billion parameters. It won't be able to use it in real time, right? So we have to think about that. Self-supervised learning. What if we don't have unlabeled? What if we have a lot of unlabeled data, but we want it to be labeled? Okay, this is not unsupervised learning. We have a huge unlabeled data, but we want it to be unlabeled. So how to do that, right? And lastly, this is also very cool research. It's called neuroarchitecture search, and that is finding the optimal micro and macro architecture for a neural network, right? So I guess that's it for today. Hopefully I don't speak too much technically, and hopefully you get a good idea about deep learning. Thank you very much.
Thank you very much, Dr. Jackie, for the comprehensive presentation. So we have listened for the presentation from the history until the research trend on this topic. So now let's continue the session with the discussion. And the main session is the discussion. So we have some questions from the student. First, let's take the question from Alpan. Alpan has two questions. First question is why can deep learning be separated from deep
questions on the chat maybe?
I think and then
so
sorry.
Yeah, there are a few. Yes.
The second question is there a relationship between convolutional neural network and character recognition? So you can see from chat the question from Mr. Taufan Saputra. I think we can start one by one.
So maybe I can answer Mr. Topan.
Yes.
Sayaputra question. So the first question is why can deep learning be separated from deep network? I'm not sure the question, but deep learning is basically you have to understand the neural network is basically a layer, right? So a simple neural network is basically the perceptron, right? And it's already invented back then, 1950, right? But deep learning is the idea of how to stack this neural network into layers, right? So neural network is each of the perceptron, right? But if you stack them together, you have a deep network. And then the way to learn using this deep network, we call deep learning, right? Is there a relationship between convolutional neural networks and character recognition? Yes. I think if you want to scan something, right? I could not imagine that you're not using CNN, right? And probably you're using YOLO, right? To recognize some character. So yeah, convolutional neural network is the model for character recognition. That is a relationship, right? The CNN is the tool, and the character recognition is a task, right?
Okay, let's continue to the next question from Mr. Indra Aulia. He has two questions. First is, when should our research use deep learning? Is there any specific criteria? And then the second question is, how many data should be given if we use the deep learning approach? Is there any specific minimum data? For example, 3,000 is enough, or we need more?
Yep, very good, very good. When should the research use deep learning for complicated stuff? Maybe to answer this, I want to answer what is not suitable for the deep learning, right? One good example is sales forecasting, right? You don't really need deep learning to forecast sales, because the relationship is very well defined, right? There's just some few columns that actually predict sales, right? So a very sophisticated regression should be able to do the job, right? Predicting number of COVID cases, maybe you can. It's arguably using deep learning, but sometimes it's not really necessary to use deep learning, right? Deep learning is useful for understanding non-linear relationship, images, text, signal, right? Although the complicated stuff that requires a lot of layers of learning. So yes, I think the key is not to overuse deep learning, and sometimes you should also compare with the classic machine learning algorithms. How many data you need? This is not easy. This is not easy, but maybe to understand your question, for the ImageNet, the ImageNet have 2,000 image per class, and they have around 40 classes, right? So I don't know how much in total, but that is actually enough for the ImageNet. So the answer for you, if you say 3,000, probably 3,000 per class, right? Per class. But if 3,000 for the whole data set, and also including test data set, maybe it's not enough, right? If you're talking about a whole data set, it must be at least, I would say 100,000 up, right? 100K up. Yeah.
Okay, thank you. Let's continue to the next question from Mr. Heru. Nice presentation for Dr. Chaklam. With the current limitation of machine learning and deep learning, especially for the data, is the knowledge graph able to improve the machine learning and deep learning capabilities? And what do you think are the current research trends related to knowledge graph?
Yes, definitely. I think there's a type of neural network called graph neural network, and it's actually popularized by Stanford. And because graph can contain a lot of spatial relationships, right? So that if you try to do some text analysis, it can actually understand not only the co-occurrences between neighbors, it can also understand the co-occurrences between a lot of text together, right? So yes, a graph create another representations, and is extremely useful to understand, especially for text analysis. Yes.
Okay, thank you, Chaki. And regarding the previous question from Mr. Indra, that I think it's a good question to be reminded by all the students that the number of data should be considered if you want to play something with deep learning, machine learning research, because for previous experience in the maybe the research seminar or maybe the final examination, that many students has problem with the number of data, and also when they try to define something new or improve the let's say the algorithm.
Yes,
So let's continue to the next question from Mr. Randi. Is it possible for an AI system to be made
yes,
minimal training data but could produce high accuracy? They have so many journals about.
Yes, of course. I think the idea. the idea is super good, right? And I want to point you to something called few shot learning. Maybe I can type in the chat, right? Few shot learning or zero shot learning, right? And the idea is super simple. That is, if we can analyze instead of classify, we understand the similarities. So the loss is the similarities. Then we only need 1 or 2 samples, and then we can actually classify. So this is a very, very in-trend topics that if Mr. Randy or Professor Randy wants to work out, please do so. Yes. So yes, it's in the area of few shot learning.
I think that's the answer could give an opportunity for the students still considering what type of research could be done for the study, at least for your studies. And next question, we have Mr. Mufli. Thank you for the presentation, Dr. Chaklam, Mike and me. In supervised learning, is there any limit for level training set to get more effective accuracy and precision? Like the limit is 5 for level or less, or it depends on the algorithm?
Yes. So there are really no limits. For example, ImageNet is 40 classes. So that means there are 40 is a long encoding of one-hot encoding of 40, right? So there's actually no limits. Of course, some algorithms requires you to change that. I mean the representations of the 40 classes. But I believe that there's no limit for most of the algorithms. Yes.
Okay, thank you, Jackie. Next question from Mr. Amit. Has there been any research regarding application of machine learning in network security, perhaps the unsupervised learning of differing network attack attempt or differing cryptanalysis attack?
Oh, I think there's a huge amount. I would say huge, and the idea is just to feed in the data of the normal behavior of the traffic, right? And it's come with the network traffic numbers, right? But then you chop the window, right, into window, and then they call this a sample, and then feed it to the data and say that this is normal, right? But then using supervised learning, you can actually classify, you can actually cluster that, hey, this is anomaly because this never happens before across all the data set, right? So it's extremely prevalent in the network security.
Okay, and then the second question from Mr. Amir regarding the ethic, maybe is it possible to apply the 3 laws of robotics as proposed by Asimov to protect us from abuse of AI?
Thank you very much, Mr. Omar. Yes, yes. At least we have some laws, and no, because humans are very, very good at interpreting different words, right? Even in the laws, there's so many things that is not well defined, right? For example, what is humans? What is volunteer, right? So if you look at different phrases of the law, if humans did not carefully think about it, there's so many ways to interpret, right? So the problem is with the humans, not with the law. That is, we don't have a collective understanding of what it should be. So that would create a problem. Yeah, but probably not in my generation. Maybe in your generation or your next generation. Yes.
Okay,
Thank you very much.
Okay, that's the last question from the chat. Maybe for all of you, anyone who like to discuss directly with Dr. Chaklam, you can ask directly. If you have problem with some English, or I will try to help you to let Dr. Chaklam understand the question. It's okay. You can try ask directly to to Dr. Chaklam. Any other question? Okay. Maybe you can you still have some, I think about 20 or 30 minutes to continue this session. Maybe before we continue the question from the participant, let's maybe I would like to ask the situation of your brain lab. Maybe do you have any student from Indonesia in your lab?
Oh, yes. Actually, she graduated already. Her name is Widya, right? And she is working on using LSTM and deep learning to predict the COVID cases, right? So she combined the textual features of the news together with the COVID cases and combine them. So you can imagine as a cross model and then try to predict COVID cases. And her accuracy is very, very high.
So she's in the master degree or doctoral degree?
Master degree.
Master. So
Yes.
how about the research opportunity for the student? Maybe, for example, maybe some students would like to continue their doctoral degree in your lab or how?
Oh, definitely.
What kind of research interest? I saw in your presentation that you're doing in your brain lab how to translate the brain signal into some kind of specific image based on their imagination, right?
Yes. So in my lab, mostly I do two stuff. First is about brain signal, right? And mostly for health and well-being, right? The second topic is for NLP. So I do a lot of deep learning on textual features, applied and theoretical. And the third one is the health, human health. So I analyze something like blood sugar using spectroscopy, Raman spectroscopy, and the molecules under the skin. Right. So yeah, any students who are interested to do the PhD, yeah, feel free. There are a lot of scholarships in there. Yes.
Okay, I think that's a good opportunity for all of you students. I mean, if you'd like to conduct some interesting research that related with Dr. Chaklam work in his laboratory, specifically in brain and text processing. And we have more question from Mr. Ivan. The question is, deep learning with computer or software with high specification from your experience, what is the minimum specification for processing text or image in deep learning? Maybe for
Okay. Maybe I can answer this. Yes, I think for deep learning, you need a GPU, all right, with at least 12 gigabyte RAM, right? GPU you can buy 2060 to 3080, right? Or you can also go to Quadro, right? Or you can also do the Tesla. But anything lower than this will not give you a good life. Yes. And for CPU, I would say 4 cores, 8 threads would be sufficient. But a lot of the times, if you have a lot of threads, then you can spawn a lot of VM machine, right, for your labs. So a lot of your lab members can do a different VM machine. Then you want a lot of threads. For RAM, I don't have any comments. 16 up, it should be good. Yep.
okay, I think that's the best practice recommendation from Dr. Chaklam for you that would like to conduct such kind of research. You can consider this specification, but also you can compensate if you cannot afford. If it's not affordable for you, you can try to how to optimize your available machine to get the function that you would like to achieve from your research. Okay, and then now let's discuss about the progress of your research in your brand lab. Could you share in more detail what is the current status, the progress of your work with your team in the brand lab?
Yes. So we are actually doing a lot of stuffs. Maybe I can. Right. So we actually do a lot of stuff. I have a total of around 30 masters and PhD students. They are doing variety stuff, but mostly they are all doing deep learning. So one part is doing brain. So they are focusing on artifact removal, some techniques in brain, some do emotion recognition, right? Combining face and EEG, combining heart rate and EEG, right? Cross-modal learning, try to convert brain image to signals. Text, we are doing a lot on future learning, so that we're trying to figure out how do we do zero-shot learning, for example, in the intention recognition task, right? We are doing cross-lingual tasks in which we try to detect fake news in a 6-language data set. We are learning how to do transfer learning in a depression detection task. So we want to detect the depression in the social media, but across domain, for example, across Twitter, Facebook, Reddit, and etc. Right? And try to see whether we can create a model that can transfer the domain across data set in which we can detect the depression. Right? We are doing a lot of applied NLP. A lot of my students like to do like text summarization, text to image, right? So yes, there's just a lot of things that we do, and we will have a lot of good news by end of December. Yes, because a lot of papers is finalized.
Okay, I see that. Let me check if we have another question from the participant. We can ask directly to Dr. Chaklam or can text in the chat. No question? Okay. Thank you very much, Chaki, for the very interesting presentation and discussion with our students. So I hope for all the students, especially, you have, I think, many good idea, many interesting research topic for your research. So from today, I think you should have no more problem with to decide what kind of research topic you'd like to conduct for your master degree or doctoral degree, especially related with machine learning and also deep learning. I think Jackie is open for us. If you would like to ask a question directly or another discussion with Jackie, if you have research interest related with brain and text mining, something like that, so you can ask Dr. Chaklam directly. So I think that's the end of our session for today's general lecture on the advanced machine learning. Once again, thank you very much, Dr. Chaklam, for the presentation. We hope we can continue our cooperation for next year for another lecture or another research collaboration. So we hope we can continue this journey with another interesting activity related with our research each other. So I think that's the end of the session with Dr. Chaklam from Asian Institute of Technology. I hope all of you could get good insight and have many things in your brain that you want to decide A, B, C, D, something like that after the the last 90 minutes that we spent with Dr. Chaklam. Thank you very much, Dr. Chaklam, for the presentation. And I give the session back to the Master of Ceremony. Please, Mr. Indra Awani.
Okay, thank you very much, Dr. Chaklam, for your presentation. It's very interesting for us. And thank you, Dr. Ade. Finally, we come to the end of the event. On behalf of Faculty of Computer Science and Information Technology, Universitas Sumatera Utara, we would like thanks to Dr. Chaklam for interesting presentation. And thank you to all participants for active participation. Hopefully the COVID pandemic can be over as soon as possible, so we can meet directly in the classroom physically. And we hope that Dr. Chaklam may come to Indonesia one day, not only sharing your knowledge, your experience to us, but also we can collaborate in the research together. And you can also look the wonderful of Indonesia. Thank you and see you the next event. Stay healthy and happy. Bye. Assalamualaikum warahmatullahi wabarakatuh. Good morning.
Thank you very much, Chapi.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, sir.
Thank you, Dr. Chaklam.
Bapak Ibu, kami mohonkan untuk mengisi link absen dan survei sudah kami perbaiki. Mohon sebelum meninggalkan ruangan. Terima kasih.
Nggak ada foto session ya?
Sudah tadi pagi.
Udah
Tadi di awal, Pak Amir.
Ketinggalan. Ketahuan yang telat joinnya tuh. Oke, mantap. Oke, izin deh